Today we are going to talk about domain and range. So first we need to define what means domain and what means range. So the domain of a function, which means the all x value of the function, and the range of a function means the all y value of a function. Since the domain of a function means all the inputs has to be defined, so here comes an example of the question. So f of x equals to the square root of x minus 6. So now we need to find the value of x in this function. Since the x value has to be defined in the function, which means we're looking for the point which it cannot be defined. As we know the characteristics of a square root, that if any number inside the square root is equal to the negative number, which means the square root cannot be defined. So now we are looking for the x value has to be bigger or equal to 0, which means that x minus 6 has to be bigger or equal to 0, which means x must be bigger or equal to 6. And this is the domain of this function, which it can be also written as x equals to include 6 to the all positive infinity real numbers. Then to solve the range of this function, as we know the property of the square root, that it has to be bigger than or equal to 0, which means the answer will be bigger than or equal to 0 as well. So the y value of this function will as well be bigger than or equal to 0. And this is our range of this function. So now we are going to calculate the domain and range of a quadratic function. Here comes an example of y equals x squared plus 4x plus 4. And now you can see the quadratic function, when it graphs it, it's a parabola. And it can face upwards when it's positive and it face downwards when it's negative. So now we know its property. And when we are calculating the domain of this function, as we know the parabola's property, that the x value would be extend infinitely. So the domain of this function would be all real numbers. And when we are looking for the range of the function, it will be really easy. So we first look at the function itself, as we recognize that the function is a positive. As we know, the vertex of this parabola is the minimum y value of it, so that the range of this function is all the numbers above the vertex. Here comes the solution of how to solve the vertex in the standard form. So now we have this, which is the standard form of a quadratic function, and then we actually can transform it into y minus c equals ax squared plus bx. Then we use completing the square, we got this, and then by solving all the problems until we have y minus c minus b squared over 4a equals to a times the x plus b over 2a squared. And then we take out this part and this part, which is the vector of this quadratic function. So in this function, we know the a value equals to 1, the b value equals to 4, and the c value equals to 4 as well. And then we only need to plug in the a, b, c into the vectors, into the equation, which means negative 4 over 2 times 1 and 4 minus 4 squares over 4 times 1. In over calculation, we learned that the x value equals to negative 2 and the y value equals to 0, which the vertex of this parabola equals to negative 2 and 0. And after we zoom into the graph and find the vertex, we would see the vertex of this parabola is negative 2 and 0, which is what we get. So the range of this function will be the all real numbers that is greater or equal to 0.